All right, so as promised, here's a quick video to go through two different methods to incorporate a phase shift into one of our reciprocal functions or our tangent functions. So the first method is going to have a couple more steps to it, but for some people, they might like this. And then the second method is going to talk about just using transformations, which is my personal favorite, especially with notability. It's pretty easy to actually just pick the graph up and move it. But the first way is a cool way to identify how this works and break things down. So maybe this might help you here. So the first one is called the key points method. So we're going to figure out our key values, A, B, C, and D, and then use those to get some key points as we go. So our first example we're going to use is shifting. So we have 2 cosecant of x minus 2. So we have a phase shift of pi over 2. So we want to make sure that we incorporate that into our graph as we move it forward here. Using the key points method, this is how it would go. So first, identify your different values. So A, the amplitude, is 2. B is 1 in front of x. And C is pi over 2, and we do not have a D value, so we don't need to incorporate that here. So then to start, we want to figure out our phase shift, which is C divided by B. In this case, that's pi over 2 divided by 1, which is just pi over 2, so C over B is pi over 2. Then next up, for one cycle or one full period, let's figure out our period, which is 2 pi over B. So in this case, that's 2 pi over 1. And that gives us a value of 2 pi. And then next up, what we are going to do is, in order to make sure that we incorporate a full couple of cycles of this, we are going to take our start, our pi over 2, and then the full cycle of 2 pi, and we're going to add those together. So C over B plus 2 pi over B. This is going to tell us where to stop, and we're going to start at C over B. So this means for us here we have pi over 2 plus 2 pi. Now we need to get this into a common denominator. This is the same as 2 pi over 1. So adding these together, 2 pi, common denominator of 2 gives us 4 pi over 2. So this adds up to make 5 pi over 2. So here's what this means. With a phase shift is going to give us the idea of where we're going to start our curve. So where we're going to start the cosecant curve, or in this case, as we plot, we're going to start cosine at that specific point. Oh wait, sorry, sine. I switched those here. For sine, we're going to start sine at pi over 2 and then follow our typical key points for the sine graph as we go from there. So then that means that 5 pi over 2, normally we'd stop at 2 pi, but this time we're going to stop at 5 pi over 2. So that means we'll start at pi over 2, we'll end at 5 pi over 2, and then we want to make sure that we have even subintervals in this. We're still going up by pi over 2, so that means we'll start at pi over 2, the next key point will be at pi, the next key point will be at 3 pi over 2, then a key point again at 2 pi, and then lastly stop at 5 pi over 2. So I have 4 spaces of intervals between these where I'm going to sketch my curve. So we'll plot key points at pi, 3 pi over 2, 2 pi, and then end at 5 pi over 2. So then now if we're going to sketch in sine, this gives us a nice idea to know that we're going to start at pi over 2, we're going to end at 5 pi over 2. So looking at anything else, the other thing we need to incorporate is our amplitude. And if we had a vertical shift, we could add that as well. So we're going to go up 2. So for the sine function, make this nice and skinny, we start at 0. The next key point goes up to a maximum. So at that point, this would be 2. Then we go back to 0. That would be at 3 pi over 2, the end of our second interval. The end of our third interval goes down to -2 and then back to 0. So then I'm going to change this to the dotted line. Let's trace through this. And then we can figure out our intervals are going by pi over 2. So now to get an idea of where the sine function is going to be so we can reflect it, I can keep going. So at 0, we'll be down at -2, negative pi over 2, the negative pi, we're at a maximum, and keep tracing from here. So this gives us an idea of where our function is going to be. And so then now from here, after we have graphed our reciprocal function, which is y equals 2 sine of x minus pi over 2, that was pretty easy. So now all we need to do is invert this. So remember, wherever it crosses the x-axis is now going to be an asymptote. So we will have vertical asymptotes at all of our multiples of all of our values that are over 2 here. So 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2. Oops, I missed it. Move that over. And then negative 5 pi over 2. Okay, so then last but not least, let's draw in our cosecant curves. So add our vertex, and then reflect that u downwards, reflect upwards, and we can finish tracing from here. Make sure that we go and hug our axes, but we don't cross them. And they alternate curves every asymptote from here. And lastly, we'll fill in this guy here. All right, so quick review of the key points method. If you take your phase shift, C over B, that tells you where to start. If you take your phase shift and add it to your period, add one period to it, that tells you what place to end at. All we have to do is then divide that between pi over 2 and 5 pi over 2 into 4 equal sections, 4 equal subintervals, then we're good to go. Tells us where to start and where to end for one period. Then we can trace the rest from there. The next route takes a transformations method. So first off, if I gave you y equals negative secant 2x minus pi minus 1. The thing to remember here is that anytime that we have a phase shift, we either have to factor out if there's a b value that's not equal to 1, so this is b is equal to 2, we either have to factor it out or we have to do c over b for the phase shift. So here, the first method, or in the transformation method, I would encourage you always to factor it out so that you don't forget that when there's a value multiplied in front, we have to separate it. Essentially, we're separating the value that shifts our period from the value that shifts the phase shift. We're separating those apart. So if I factor a 2 out from inside, that is going to make minus pi become a minus pi over 2. If you're not sure, distribute it back in. 2 times pi over 2 does give me the original pi. So factor out a 2. So now looking at this for our transformations method, first I would look at any special things that are going to happen. So we have a negative out front. This would be a vertical reflection. The 2 will affect the period. Minus pi over 2 is our phase shift. And then we have negative 1 will be a vertical shift. So first off, the vertical shift is going to affect our midline. I would always plot the midline first if the midline is not 0. So first, in this case, D is our vertical shift. This gives us a midline of y is equal to negative 1. So this means that the line that passes through the middle of this graph is going to be now at y equals 1 rather than being at y equals 0. So now I've retraced our midline. Now, looking at my factored form, then for the phase shift, C is going to be pi over 2. So C is equal to pi over 2 after we factored it out. And then for our B value, this is going to give us our horizontal transformation, or this is going to mainly affect our period. So in this case, B is equal to 2. So we need to figure out what the period is, 2 pi over B, so that's 2 pi over 2. So the period of this function is pi. Now we're going to take this and graph the reciprocal, which is y is equal to negative cosine of 2 times x minus pi over 2, then minus 1. Alrighty, so now we're going to put it all together. I have my midline. Next thing, this is how I'll often do this. There's 2 ways. You can either graph our function. Ooh, that doesn't look good. Hold on. Ooh. All right, we're going to cut that out in just a second. Okay, so now we have a vertical shift of negative 1. We have a phase shift of pi over 2. This means our entire cosine graph needs to be moved right pi over 2, and then we have a period of pi. What I encourage you to do is first start and graph the function as if there was no phase shift, and then we can literally, on notability, move it over. So in this case, if we're graphing on notability, my period is pi. That means that I need to divide it into 4 equal subintervals, so I will have a key point at these 4 indicated marks: pi over 0, pi over 4, pi over 2, 3 pi over 4, and at pi, and then it will repeat from there. So in this case, we're going every single line for our different key points. We're going to another one. So then for the phase shift, let's first sketch it as if there weren't one, and then we'll move it. So my key point, we're going to start, and what's our amplitude? So it is a minus. So we are going to start down 1. So this function is going to start at 1 below the midline. Then at our next point, we're going to come back to the midline. Then we're going to go 1 above the midline, 1 below, and so on and so forth. So what I'm going to do now is use the highlighter and trace through. So 1 below, back to the middle, above, to the middle, downwards, to the middle, back up. Okay, so right now I've drawn a little more than 1 period. So if this is moved to the right pi over 2, this point that starts at 0 needs to shift and move over pi over 2. This is what I do like. I'm going to make this a little bit skinnier. And let's make it dotted. This is what I do like about using this method on notability, is we can actually move it over to the left pi over 2. So now let's go backwards and finish this off. So that would take us back to 0, then above, back to the midline, below, back to the midline, above, back to the midline, below, back to the midline. And then let's make this dotted again. Okay. All right, so now here is our transformed version of cosine. Now, looking at this, it's interesting. The cosine of with a phase shift of negative pi with a negative out front, it just actually sort of looks like a regular cosine. So that's something to keep in mind here. Now, in this case, our asymptotes are going to be wherever we cross our midline. So we're going to have asymptotes again wherever our function intercepts our midline. In this case, this looks like it's at all of our pi over 4 values. Okay. An alternative, just to point this out if you're thinking about it, is rather than just physically moving it notability, you also, if you figure out where you're supposed to start at 0, jump to that point at pi over 2 and start your pattern from there. That's also a perfectly good way to do this. All right, last but not least, let's finish this off and trace our curves. That one's not liking me. Okay, let's go. Then we're at 0. We trace up here. Then we're at negative 2. So what we can see is all of these curves have been moved downwards. They're still centered, and they're centered around our midline, but they have all been shifted down 1. All right, we've got a bunch of curves we can plot on this one. Multiple periods showing up here. All right, and that is it. So you get to pick which one works for you, whether you just like to, the idea at the end is we have to use all of our transformations. We have to think about what each value incorporates into it. There's no avoiding thinking about what the amplitude does. We have to sort of figure that out on our own. But it's up to you of whether you like this key points method of figuring out, all right, I'm going to start at the C over B value. I'm going to add 2 pi over B. That's where I end, and I'm going to break it down in between it. Or it's not really all that different, except we need to, with transformations, separate them out. Then we can identify A, B, and C just like this, and then that helps us figure out how to physically move the graph. So rather than me telling you where to start, we're thinking more about transforming, taking the original, shifting it to the right, shifting it down, stretching it, flipping it, all those different transformations. So hopefully this will help you as you finish the graphing homework in terms of our reciprocal functions and use this as a resource. Let me know if you have questions, and we'll go over some more of this next time that we are together.